Hello, mentors. Welcome to meeting 5, part 1. So this is part of the separation activities. And let's take a look at the 6 case and 8 case from this part. So remember, we're in the situation where a shape is happy if at least one neighbor is like that shape. So it has to have at least one neighbor that has the same shape. And we have these two types of shapes, triangles and squares. So if we had 6 shapes, 3 triangles, and 3 squares, first we would ask, what are all the configurations in which all shapes are happy? And so we want to list them. Here's the solution. Actually, when we have 3 and 3, only 2 solutions are possible. SSS, TTT, and then the mirror solution, TTT and SSS. So we discovered that we need a full separation. We cannot have, for example, a T here and an S here, right? Because then this T would only have neighbors that are different and it needs one. So if we place this T, then we need a T here and this T, that's fine. We could have here potentially an S. That's what we could try. Let's try. And if we had an S here and a T here, then this would have to be an S, because if it's a T, then this is sad, right? So this would have to be an S. This could be potentially an S or a T. But you see that in either case, then this T would be sad. And so if we switch it to try to fix it, then this T would be sad. So you end up in something that's impossible. At some point, you're going to lose the game either in the middle or at this end. So it's impossible. So we need full separation. So have students reason like that in a general sense. You can make even a longer board for advanced students to reason in the same way, see what happens. So here's the explanation in the solutions, so you can read all about it. Now we change a little bit, just by what if we have some imbalance of 4 triangles and 2 squares? Do we have more configurations? And potentially yes, because then maybe we can just make the squares happy, take care of that. And there's more triangles, it may be easier for them to be happy. So we end up with a new solution, so to speak. So these are similar to these ones, where you have all shapes on the left and the other all shapes on the right. But we actually end up with this nice situation in which if we place them right at the middle, the 2 squares, they're going to be happy because they have at least one neighbor of the same shape. And of course, the triangles are super happy, usually here. So it's all good. Can we do this? Let's just investigate this block of 2 squares. Could they be here? Actually, no, because then the triangle here would be sad. So it's a very delicate solution in which the 2 squares must be exactly in the middle. Same for here. If I put them here, this triangle would be sad. And finally, what if we had 8 shapes instead? So we make a larger board and then we have 4 and 4. What happens? Do we get more solutions? And then this reasoning would be good place for this progression, so a good scaffolding to attack now this. Mainly what we see is that we cannot have these sandwiches, so to speak, STS or TST, when we build our solution, because then this would be unhappy, right? The one in the middle. And I even, stronger observation, same idea, but richer, is that we cannot have an SSSTT. So we cannot have an SSS sandwich between 2 T's. That's because then if you put this 5 somewhere here, so remember, it's a sandwich. You put it anywhere here, the other square would be isolated, right? Wouldn't have another neighbor. There's only 4 squares. So what ends up happening is that when you rule out these 4 mini configurations, right, then you don't have much possibilities, and you will count the 6 solutions as these ones that are very familiar now for us, and then these that are blocks of 2, right, where you vary. Well, not always, but similar. You can see that in all these configurations, everybody's going to be happy having at least one neighbor, and that everything else that you try to do will generate these 4. So it's not going to be possible. So of course, 2 is more challenging than 1, and just bear with students and see how they are level-wise and in terms of how they're reasoning, and just try to push them towards generality. The last question is just a summary, what is the same and what's different between these 2 cases. And we saw a big explosion of solutions here because we had more room. More advanced students could actually generalize or extend this reasoning to longer one-dimensional maps. So that's the video. Hope you enjoy it, and see you in the next one. Bye.